Hi everyone, welcome to the class once again. I hope you're all doing good and in the best of your health. So up till now we have studied the concept of nucleus. We have seen that what particles comprise of nucleus. Today we'll be seeing the topic of radioactivity. And let me tell you, it's very interesting and it has got a lot of application in our day-to-day life about this concept that is radioactivity. First of all, before starting radioactivity, how it was discovered. So first of all, we'll talk about discovery of radioactivity. Now, most of you in your childhood, you must be knowing that it was Pierre Curie and Madame Curie who were actually responsible to discover the concept of radioactivity. And even there's a renowned scientist behind this, that is Henry Becquerel, who is actually credited with this discovery of radioactivity. Henry Becquerel was the one in 1896, he discovered the phenomena of radioactivity. Henry Becquerel in 1896, he was credited that with the discovery of radioactivity. And let me tell you how it was discovered. It was an accidental discovery of radioactivity. He found out that photographic plates got exposed when they were placed near uranium and zinc sulfide plates. It was getting exposed. Uranium plates, uranium, it was placed near the photographic plates were getting exposed. Now, later on, it was Madame Curie and Pierre Curie who were actually found that some more phenomena related. Madame Curie and Pierre Curie, they found out that even there are some more substance which can give more intense rays compared to the rays coming out from the uranium. And those rays they termed as the radioactive rays, and we'll talk upon those rays what were actually they were comprised of. So first of all, these people are actually responsible and credited with the discovery of natural radioactivity. So they have actually discovered the phenomena of natural radioactivity, that is, it is not induced, it is spontaneous, it is automatically that is happening in the nature. Now let's talk about how to define the radioactivity. And let me tell you, radioactivity is a nuclear phenomena. So entire change of the nuclear takes place in a radioactive phenomena. And we all know that for any atom, to actually define an atom, we should know the constituent of the nuclear. That is, I'm talking nuclear, I'm saying it's the nucleus I'm talking about. And in the nucleus, we know that protons and neutrons are actually constituent particles. If they change, that means the entire element is changed. And in radioactivity, it's a nuclear phenomena, hence the inner content of the nucleus actually changes. Its number changes, the proton and neutron number may change. So entire element will actually change. So this transformation is known as the radioactivity. So the transformation of one element to other element, the transformation of one element to other element through emitting rays, instead of rays I'll be saying through emitting particles or electromagnetic waves, or rays through emitting particles or electromagnetic rays is natural radioactivity. We will understand this term. I have used particles and electromagnetic waves. I have used the term, these two terms I have used in different definition, emitting particles or electromagnetic rays. That means what is happening when one substance disintegrates and forms another substance. For example, if you take A, it gets converted to B, and this conversion is known as the radioactivity transformation or natural radioactivity. And it can take place through particle, you can say particle emission, or it can also take place through electromagnetic wave emission. So how can we understand that which particles are coming out or which electromagnetic wave is coming out? Let's talk more about this. And these things can only be found out with proper experiments that have been performed, proper experiments set up, we can only find out. Now let's go ahead. For radioactivity, I told you that photographic plates are getting exposed. It means through the radioactive substance, there are some particles or rays coming out which are actually exposing the photographic plate. There will be some particles or rays. So it was Rutherford who performed an experiment, and he came onto a conclusion. What he did, he took a radioactive substance. Let's say this is a radioactive substance, and there was a detector placed at a certain distance from this. Let's say there was a detector placed at a certain distance from it. By detector we mean that it will detect whatever the radioactive rays are coming out of from this. Now what he did, in between these two, radioactive substance and detector, he kept foils. And this foil width is variable. It can be very thin foil, and we can actually change the width of the foil. This foil width is variable width. So it's up to you, however you want, you can take control of the width of this foil. Now whatever the rays are coming out from this, they are going to cross through this foil, and finally they are going to come on the detector. Rutherford tried to measure the intensity of the rays coming out from it, and he plotted a curve for the intensity and for the width of the foil. Let's see what kind of curve he actually obtained, and which led to certain results, certain conclusions that we can make out from this. What he did, he actually plotted the intensity. The curve was something like this. He plotted the intensity here, and he plotted the, let's say, width of foil here. What happened initially, if I show you how this intensity and foil width curve was moving ahead. So intensity was initially high, and suddenly it came down. And let me mark this point as A and B, and then let me show you the second curve was something like this. Let me say this is C, and the third curve was something like this. Now what conclusions we can make out from these curves? What conclusion we can make out? A, B, B, C, C, D, this kind of curve you obtain. You see here, initially the intensity was high, but suddenly it came down. Here what happened in AB, it was due to absorption of one kind of rays which was named as alpha rays. We'll talk upon this alpha rays. In BC, you see the intensity came down gradually. It was not an instant, intensity was not decreased, it came down gradually. This is due to the absorption of beta rays. Now in this part CD, you see the slope is still lesser. This is having a high slope. You see it's decreasing, and it's still decreasing at a very slow rate. Very slow rate is decreasing. It is due to the absorption of gamma rays. How to understand the three kind of absorption that I have shown you here? First of all, see absorption of alpha rays. What's happening? Alpha rays are having the low penetrating power. So as the width is increased, all the alpha rays are absorbed. So intensity due to the alpha rays that came out, suddenly it's lost. So intensity came down here. Now as the foil width is increased, as you can see on the x-axis, this curve is falling in this way. And gradually the beta rays is absorbed. Beta rays are having more penetrating power compared to the alpha rays. But as you increase the foil width, beta rays are going to be absorbed, and gradually the intensity of beta rays is lost. So here finally the curve reaches C, point C. Further you increase the width of the foil more. What is going to happen? More rays are going to be absorbed, and this time the absorption of gamma rays is taking place, and the gamma rays are having the highest penetrating power, and hence they are absorbed as the foil is increased. But since it's got the highest penetrating power, this rate of intensity fall is quite low here. We can see the rate of decrease of intensity fall that is quite low. Rate of decrease of intensity that is quite low in case of gamma rays. So three kind of rays were actually discovered by this experimental setup. Radioactive substance is going, it's placed here between a detector, and between the substance we have placed a foil. As you increase the foil, you are going to absorb the radioactive rays that is coming out of the radioactive substance. Now we got that these radioactive rays are comprising of three kind of rays: alpha rays, beta rays, and gamma rays. Let's understand the property of this alpha rays, beta rays, and gamma rays. One thing we got from the experimental setup, that the alpha rays would be having the least penetrating power. Least penetrating power, and hence it was absorbed very early. Least penetration, let me keep a least penetration. Now let's talk about beta rays. Beta rays has got more penetration compared to the alpha rays, but it has got less penetration compared to gamma rays. So here I am marking here more penetration. And gamma rays, you see here, its intensity, it is absorbed lastly. At the end, lastly it is absorbed. After alpha rays is absorbed, beta rays is absorbed, it is absorbed lastly, and its rate of fall of intensity, rate of decrease of intensity is also quite less. We can say that it has got the highest penetrating or highest penetration it has got with it. So let me write here gamma rays, let me write here, it has got the highest penetration. Now still we do not know about the properties of these alpha rays, beta rays, and gamma rays. We got that they may be particles, they may be electromagnetic waves, but we only know about their penetration. So what to do? Take note till here. Let me start at the other end, take note till here. Now to understand the properties of alpha rays, beta rays, and gamma rays, Rutherford performed more experiments to understand whether they are carrying some electric charges with them or are they neutral. So the experiments performed were, first of all, to understand the charge part, whether they are having charges or not. What he did, he actually took a lead box, and in this lead box he made a very small cavity in this way, and in this cavity he placed the radioactive substance. Here we have a lead box, and this is the radioactive substance. Next thing, we all know that whatever radioactive substance you're going to take, radioactive rays will be coming out, and here we have the rays are coming out in this way. And what he did, he actually applied an electric field here. He applied an electric field in this way, such that this is a plus plate, let's say. This is a minus plate. So an electric field is applied. So as the rays were coming out, what he did, he kept a screen over here. I hope that you can clearly see till the upper end. This is the screen, and the entire setup is kept up in an evacuated chamber. The entire setup is kept up in an evacuated chamber. Now from here, this entire chamber is closed. Let me close it. Entire chamber is closed. So as these rays were coming out, see what happened. He found out that some particles went like this, some particles moved straightway, and there were other particles which actually moved, making a larger radius. These three particles, what he did, he mentioned it as alpha ray. This is the property shown by beta ray. We'll understand why this is so. Just now I'll tell you the reason why they has taken one as alpha ray, one as beta ray, and this one as the gamma ray. Why is that so? This is deviating towards the negative plate, that is toward this side, that means it is having positive charge. And here the beta ray is deviating toward the positive plate, that means opposite to the electric field, hence it is having negative charge. This is moving straight, undeviated. That means it is having no charge, it's neutral. So the conclusion that we can make out from this, alpha ray is positive, beta ray is negative, and the gamma ray is neutral. And the radius also, you see, alpha ray has made a very small, this larger radius and very small deviation from the straight path. Beta ray has made a smaller radius but larger deviation. That means the mass of alpha particle will be quite high. The mass of beta particle will be quite less. That is what we can actually make out from these three curves. Next, what he did, the entire setup, instead of applying an electric field, what he did, he applied magnetic field. So again, one more experiment he performed in a closed chamber, in evacuated chamber. What he performed, one more experiment. Again, he took a lead plate, kept the radioactive substance as already we have seen, kept the radioactive substance, and this time he applied a magnetic field here. And then again there was the screen which is placed here. This is the screen, this is the area of magnetic field. Now let's say this magnetic field is moving into the plane of fiber. So I will draw a very less sign, let's say magnetic field region, and magnetic field is into the plane. In this way he applied. Now what will happen? Radioactive rays will be coming out and they will be under the effect of this magnetic field. What you observed, there were some rays which were moving undeviated and some moved in this way and some moved in this way. Again, if you see this undeviated ray, no effect of magnetic field, these were gamma rays. Large deviation, beta rays, and here this was the alpha ray. Based upon these two experiments, we can easily comment on the charges present on these three kind of rays or particles that we are obtaining. Alpha rays and beta rays are going to have charges because they are deviated by this electric field and magnetic field. We all know that a moving charge gets affected due to magnetic field, and normally a charged particle gets deviated due to an electric field. So let's talk about the properties of alpha rays, properties of beta rays, and properties of gamma rays based upon this experiment. First of all, what are these alpha rays, what are these beta rays, what are these gamma rays? See, alpha rays, they are doubly charged helium nuclei, or it is helium nuclei. Already we know that helium nuclei can be represented as helium 4He2. Beta rays, they are nothing but actually accelerated electrons. You can treat them as electrons. They are actually electrons. And gamma rays are simply energetic photons. Energetic photons. Now if we talk about the properties of all these three, let us talk about the properties of all these three. So we are going to obtain properties of alpha ray, Alpha ray, already we know that it's got positive charge. It's a helium nuclei. It means it's having a positive charge. It's heavy. It's heavy. It has got positive charge. So it's a positive charge particle. Its penetration power is less. Low penetration power, or penetration power is less, or penetration effect is less. It's heavy, so penetration effect will be less. That's quite obvious for us to make out. Third thing, it has got mass that is 4 times the atomic mass unit, and it's a helium mass, so it's got higher mass compared to beta and alpha particle. Higher mass compared to beta particle. Now, since it is doubly charged, it can ionize. It's got very high ionizing power. Ionized atom, it has got high ionizing power. After this, let's talk about, and more things we can talk about. It has got velocity, it has got energy, and we have got already the penetration effect and the mass and the ionizing power. These are the 3 important properties. Now if I talk about the properties of beta rays. Properties of beta ray. If I talk about this, first of all, first thing, it's a negative charge particle as per the deviation that it has shown. It's a negative charge particle. Has the mass of electron. It has the mass of electron. Third thing we can say, if I compare the higher mass compared to beta particle, since it has got mass of electron, that I have written a penetration effect. Penetration effect is more compared to alpha particle. It's got high penetration power. You can write it as high penetration power, and it can also ionize atom, because a negatively charged particle, it can ionize atom. And let me tell you both, one more property you should also write here in both the, they can initiate radioactivity in other substances. They can initiate radioactivity in other substances. And for beta also you can take one more property. It can also initiate radioactivity in other substance. When they are bombarded against other substance, they can initiate radioactivity in other substances. So now we are left with the third one, that is the gamma rays. Let's talk about the properties of gamma rays. Gamma rays, if I talk about, first of all, they are having no charge. I'm sorry. First of all, we know that it was not deviated by electric field and magnetic field, so it is a neutral part. It is a neutral. It has got no charge. Let us write here. Second thing, it's an electromagnetic. It's an electromagnetic wave or photon you can take. And after this, some more properties if you mention, it has got the highest penetration power. Since it has got no charge, so it cannot ionize atom. does not ionize other atoms. No charge, so it cannot ionize other atoms, as we can see here, and it can also initiate radioactivity. Can initiate radioactivity in other substances, and its velocity, since it's an electromagnetic wave, its velocity is equal to velocity speed of light. Its speed or velocity is equal to speed of light, since it's an electromagnetic wave. So what we finally obtained? We obtained that alpha rays and beta rays are actually particles. They are doubly charged helium nucleus, this is electron. And gamma rays is what? It is electromagnetic photon. It has got energy, it's an electromagnetic photon, it's got the highest energy. Both beta particle, alpha particle can also move, gamma rays is also moving. Now we'll talk upon how this actually alpha particle and beta particles actually emitted, and what are the effects and what are the reactions that are taking place. We'll talk about more about this in the next lecture. So till time, thank you everyone for joining with me here. I'll come with new concepts and something more in the next one. Wish you all the very best, and thank you everyone.